name's Shoshanna. I generally go by Shosh, and I'm a planetary geologist. So I look at rocks on Mars. I look at rocks on Mars using space robots. That's what I do. So I don't build them, and they actually were on Mars before I even got into this. The people who do the building of robots are engineers, and then the people who make them operate day to day are also engineers, and the people who say what they want the rovers to be doing are scientists. So scientists have questions that they want answered, or they see rocks that they think look interesting, and they say, let's go look at that rock using these different instruments. I used to work in high energy physics, which is particle physics, and I was living in Australia at the time. And after a few years, I realized that I hated what I was doing. And it took a while for me to actually figure out that what I was doing research in was making me miserable. And once I did, I knew I wanted to do a PhD in something else, but I didn't know what. So I contacted a bunch of my professors from where I went to college, which was in the US. And and so I had some conversations with them about what types of fields there are and what I could go into. I'd majored in physics as an undergrad. And then I talked to another mentor who said, well, think about what you can't help but know. So if you're looking in a newspaper or you're reading a general science journal like Science or Nature, which have lots of different topics as opposed to only physics or only particle physics, and just think about what articles you end up reading. And at that time, I could have told you all about everything that the Mars rovers were doing, Spirit and Opportunity. And then I applied to do a PhD in planetary geology. A lot of people have speculated that there could. We have no evidence that there are, and with Spirit and Opportunity, we would not be able to see if there were. So Spirit and Opportunity are there to see if there might have been liquid water on the surface of Mars in the past. And that's all very, very qualified. They're water, right? But so it's not just water as opposed to ice, because there's ice there now, and we know that. On the surface of Mars, as opposed to deep down, you know, like buried under lots of soil or rocks. And in the past, because there couldn't be water now on Mars because of the pressure and temperature on the surface. So what we're looking for is things like minerals that only form in water. So there are some minerals that have water inside the crystal itself or as part of the crystal itself, and you can't form those without water. And both Spirit and Opportunity have found some of those minerals, not like a huge chunk of it, but in with all the other minerals that make up a rock. So because of Spirit and Opportunity, we know that there was, once upon a time, some liquid water on the surface of Mars, or at least close to the surface. But that water was, most of what we've seen, it was likely to be very, very, very acidic. And there are some bacteria and archaea on Earth that could survive in those acidities, but we don't know that life could develop there. They're only a very small fraction of the rock. So it's not like there's something there that you could mine for water. If you wanted to make use of water, if you were on the surface of Mars and wanted to make use of water on Mars, you would probably go to the polar caps and use the ice that makes up the polar caps. And we've also now seen evidence of glaciers covered in soil, it's not soil like you would think of it, covered in bashed up rock and dust, closer to the equator, probably around where Ithaca is, close to the equator. And so if you wanted to use water, you would use that. But these rocks, the importance of them is that they show that this area once saw water. So the scientists who are working on Mars aren't looking for things that humans could use. We're looking to see the history of Mars. So on Earth, we certainly haven't completely done it, but we have a good sense of Earth history, right? What the continents have moved, and water has risen and fallen, and living on Mars would be more difficult by far than living anywhere you can think of on Earth, no matter what happens on Earth. So volcanoes, there's no change in the rate of volcanic explosions. Well, I mean, it's much less now than it was a few billion years ago, but there's certainly no acceleration in the way that volcanoes are going off. The ice caps melting is occurring slowly, and that's really bad for coastal cities. But Mars is so out of our range of what we can easily inhabit. We would not be able to lift everyone up and send people there. My advisor, Steve Squires, when he's asked, will humans colonize Mars, he thinks no. He does not think we will ever colonize Mars. Because Antarctica is such an easier place to live. And we have not colonized Antarctica. We have scientists there, but they rotate in and out, and we don't have, families pioneering in the middle of Antarctica. And Antarctica is warmer than Mars. It snows more on Antarctica than it does on Mars. And also Antarctica is nicely encapsulated in Earth's magnetic field, which keeps a lot of radiation from coming in, which happens in Mars. Mars doesn't have a magnetic field. Mars doesn't have much of an atmosphere, so there's no way you could breathe on Mars without a spacesuit or some kind of, space colony thing. I think that eventually people would colonize Mars, because I think that the land just has beauty. Sorry, I'm looking at my picture here again when I turn my head like that. I think it's really pretty, but the reason that it will take so much money to send humans to Mars and keep them alive is Earth is such a protection from space. It's not only the cold, the atmosphere keeps a lot of radiation from getting us. And Mars doesn't have that, and however you travel to Mars, you probably wouldn't have that. You could, but it will take a lot of research to make it, and it would be very expensive to launch. So I think it will be very, very, very hard to make a large ship to bring even a few dozen people there. And 6 billion, 10 billion in the next few decades, that won't happen.
Oh.
So, okay, this is a topographic map of Mars. It goes up to like 70 degrees, so it doesn't go all the way to the poles. So in this, blues are low. They have nothing to do with water. They're just low down, and reds and whites are high. And we have a scale up here that shows that. So this is Hellas Basin, which is one of the largest impact craters in the solar system. And it's really, really, really deep. And then over here we have Olympus Mons, which is the largest volcano in the solar system. This is the size of the state of Arizona, and it's 3 times higher than Everest. This is a 25-kilometer thing. That's the height of the volcano. We have nothing like that on Earth. And a weird thing about Mars is the whole top is lower down and younger than the whole bottom, right? Because the whole top is blue if you make a wavy line. And we know that the surface is younger because it doesn't have as many craters. So if you imagine impact, like meteorites just hitting at a relatively constant rate, the longer that you've been exposed, the more craters you're going to have. We still don't understand that. We're not sure what happened to make that. One idea is that there could have once upon a time been an ocean there, but we don't really see evidence of that. Another idea is that it could be the largest crater in the solar system, being half a planet. So maybe when Mars was starting to form, something bashed into it and essentially ripped off the whole top. And then it cooled. The very thinnest part of the crust is right here.